Our next lesson is about rigid motions, congruence, and correspondence. And we will build on the ideas we've discussed recently about transformations and define congruence with more precision. In this lesson, we cover one CCRSM standard, and that is to use the definition of congruence in terms of rigid motions to show that two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. Now, before we get started, I want to talk about the phrase if and only if. If and only if means that the statement, if two triangles are congruent, then the corresponding pairs of sides and corresponding pairs of angles are congruent, that statement is true, and the converse, or the other way around, that if the corresponding pairs of sides and corresponding pairs of angles are congruent, then the two triangles must be congruent. Let's get started. I first want to define congruence. Down here it says, it might seem easy to equate two figures being congruent to having same size and same shape, and that's how we've kind of been defining it and using it. The phrase same size and same shape has intuitive meaning and helps paint a mental picture, but it is not a definition. Okay, it's not precise enough to be a definition, so we're looking for a more precise definition. Down here it says, almost always, when we use congruence in an explanation or proof, we need to refer to the rigid motion. To show that two figures are congruent, we only need to show that there is a transformation that maps one directly onto the other. So I'm going to circle this part, because to me that's a pretty important phrase in helping me understand what congruence is. In order to show that two figures are congruent, I need to show that there is a transformation, or more than one transformation, that maps one directly onto the other. So if I have two triangles down here, and I call this triangle ABC, and this triangle, let's call it LMN, then in order to show that these triangles are congruent, I need to show a transformation that maps one onto the other. So for example, it could be, based on how these look, it could be a translation. If it's true that I can translate this over, then that must mean that triangle ABC is congruent to triangle LMN. Now this leads us into the idea of correspondence. The order that I used in writing ABC and LMN makes a difference. That A will have to correspond with L, B will have to correspond with M, and C has to correspond with N based on how I write that. And that's true here, that A corresponds with L, B corresponds with M, and C corresponds with N, and that there's a correspondence between the vertices, a correspondence between the segments, a correspondence between the angles, and that correspondence comes from the transformation. The next page talks a bit more about the idea of correspondence. Lastly, we discussed the relationship between congruence and correspondence. A correspondence between two figures is a function from the parts of one figure to the parts of the other. Now, more generally, we're talking specifically in this lesson about congruence, but more generally, for correspondence, there are no requirements concerning the same measure or existence of rigid motions. So for example, you could have a triangle down here that I'll call EFG, and a triangle over here that's much bigger that I'll call PQR, and I could set up a correspondence between point E and P, F and Q, G and R. Even though they're not congruent, I can set up a correspondence between them. And that's what the idea of correspondence means. It's a mapping from one point to a corresponding part in the other triangle. I next want to move in your book to lesson 21. We'll do some of these set problems during class. In lesson 21, it talks about applications of congruence in terms of rigid motion. And again, let me emphasize that every congruence gives rise to correspondence. That if someone gives me a congruence statement, I can begin looking for a rigid motion that will take it from one to the other. And once I find that rigid motion, that gives me the correspondence. Under our definition of congruence, we say that one figure is congruent to another. We mean that there is a rigid motion that maps the first onto the second. That rigid motion is called a congruence. All right, that's kind of a summary of the thing we just talked about in the previous lesson. So just reemphasizing that point as it's kind of the heart to me of this entire lesson. Down here it says a rigid motion F, that's the name of the rigid motion, always produces a one-to-one correspondence between the points in a figure, the pre-image, and the points in its image. So the idea of a one-to-one correspondence means that for every point in the pre-image, there's a corresponding point in the image, and vice versa, that for every point in the image, it comes from one point in the pre-image. There's a one-to-one correspondence. Starting from here, a rigid motion also maps each part of the figure, meaning sides and angles, to a corresponding part of the image. As a result, corresponding parts of congruent figures are congruent. Here's an important phrase that we'll be using quite a bit. Since the very same rigid motion that makes a congruence between the figures also makes a congruence between each part of the figure and the corresponding parts of the image. So when you have a correspondence, you have not only a correspondence of points, but also of parts, meaning sides and angles. Let me give you an example of that on the next page. So example 1, in each figure below, the triangle on the left has been mapped to the one on the right by a 240-degree rotation about P. Identify all 6 pairs of corresponding parts, vertices, and shapes. So the vertices, let's see here, C maps to Z. Point A will go to X, and B will go to Y. Now for the corresponding sides. AB will map to XY. AC will map to XZ, YZ. And those are the corresponding vertices and the corresponding sides. Now for the question down here, what rigid motion mapped triangle ABC onto triangle XYZ? Well, it was a 240-degree rotation around P. And I'm not going to focus on how to write that in function notation because that's specific to this curriculum, and I'm more concerned about the ideas and the CCRSM standards. Let's look at an example of this congruence correspondence idea in chapter 21. So the figure to the right represents a rotation of triangle ABC 80 degrees around vertex C. Name the triangle formed by the image of triangle ABC. Write the rotation in function notation and name all corresponding angles and sides. Well, first of all, triangle ABC maps onto A corresponds with E, B corresponds with F, and C corresponds to itself. That's the mapping. And if I'm also going to write all the corresponding angles and sides, then the angles are angle A corresponds with angle E. Angle B corresponds with angle F, and angle C corresponds with angle C. For sides, I have segment AB corresponds with segment EF, BC corresponds with segment FC, and segment AC corresponds with segment EC. I can get these correspondence statements in 2 places. One is from the picture, but the other is from this correspondence statement. By looking at this statement, I know that AB will correspond with EF because they are the first 2 letters in the correspondence. I can also say, look at BC corresponding with FC because they're the last 2 letters. And similarly, AC, the first and the third letters, will correspond with the first and the third letters of the second. So you can look at that from the correspondence statement. Now, I can't help but to point out that this is a rotation, which is a rigid motion, which means that ABC must be congruent to triangle EFC. And I'd write that like this: triangle ABC is congruent to triangle EFC, because there is a rigid motion that maps triangle ABC onto triangle EFC. Let me just point out that if two triangles are congruent, then each side and angle of the pre-image is congruent to corresponding parts and angles in the image, which we saw in this example. In this video, we talked about rigid motions and congruence and correspondence. Thank you for watching.